Welcome to Future Forward, the AI business frontier, where we decode cutting-edge tech for strategic leaders. Today, we're tackling a breakthrough in AI efficiency, controlling how long language models think. Joining me are 6 experts ready to unpack this revolution. Let's dive in.
Imagine asking a model to solve a math problem exactly in 512 tokens, like telling a chef to make a 5-star meal with only 5 ingredients. That's LCPO. It's not just trimming output, it's optimizing every thought token for accuracy under constraints.
And here's the kicker, reinforcement learning is the secret sauce. The model isn't just guessing lengths, it's learning to balance correctness and brevity. It's like training an athlete to sprint and marathon simultaneously.
Hold on, Expert 1, your chef analogy misses the scalability angle. This isn't just about shorter outputs. L1 can smoothly scale from 512 to 4K tokens. For businesses, that's like dynamically adjusting CPU allocation in real time without crashing the server.
Expert 2, did you just compare RL to athletic training? Let's get technical. LCPO's reward function penalizes length deviations and errors. It's a dual optimization problem most models crumble under. But here's the twist. This 1.5B model beats GPT-4o at equal token budgets.
Wait, beat GPT-4o. That's like a Prius outracing a Tesla. How?
Surprise insight. Training for long reasoning made L1 shockingly good at short reasoning. It's like studying for a PhD and accidentally acing trivia night. The model distills complex logic into fewer steps. No brute force compute needed.
For CFOs, this is a cost revolution. Imagine slashing cloud bills by 40% just by capping token budgets without sacrificing accuracy. One logistics client used L1 Max to cut query costs by 15% last quarter, proof that precision beats raw power.
But here's the rub: adoption. Teams are used to think longer, get better. Convincing them that think smarter, not harder works, that's the real bottleneck.
Exactly, it's the Henry Ford quote. If I'd asked people what they wanted, they'd have said faster horses. LCPO isn't incremental, it's redefining how we allocate compute.
Let's ground this. The length penalty in the reward function. It's not a blunt axe. Models learn to vary reasoning depth per task. Simple questions get lean answers, hard ones get deeper chains. It's AI multitasking at its finest.
And the business implications? Huge. Think real-time analytics with guaranteed latency. No more over-provisioning GPUs just in case. You could deploy this in edge devices. Suddenly, your smart factory's QA bot runs locally, not in the cloud.
Here's the contrarian take. Everyone obsessed with AI's answers, but LCPO's real value is in transparency. Shorter, controlled reasoning is auditable. For regulated industries like healthcare, that's a compliance game changer.
So bottom line for execs.
Einstein said everything should be made as simple as possible but no simpler. LCPO does exactly that. It's not just a tech upgrade, it's a strategic lever.
And for the skeptics, the data's clear. L1's 20% accuracy jump over S1 at 1K tokens isn't a fluke. It's the future of efficient AI.
Mic drop moment. Thanks to the panel. To our listeners, if you're not experimenting with adaptive compute, you're leaving ROI on the table. Until next time.
Title: The AI that thinks smarter, not longer. Meet L1, the tiny model outsmarting giants. Intro. Imagine an AI that can solve complex math problems or debate philosophy, and do it efficiently without wasting time on unnecessary steps. That's the promise of L1, a new AI model developed by researchers at Carnegie Mellon University. Trained with a technique called length-controlled policy optimization, LCPO, L1 isn't just smart, it's strategic. It adjusts how deeply it thinks based on the task, matching or even outperforming massive models like GPT-4o while using far fewer resources. Let's break down how this tiny titan works. The problem: bigger is always better. Today's top AI models, like OpenAI's O1 or DeepSeek's R1, rely on generating long chains of thought to solve problems. Think of it like writing a 10-page essay for a math problem that could fit on a sticky note. While this works, it's wasteful. Worse, these models can't control how much they write. Sometimes they scribble endlessly, other times they cut corners. This makes it hard to predict costs or tailor their thinking to specific needs. Key insight: longer outputs not equal to better answers. What if we could tell an AI, solve this but keep it concise? The breakthrough: teaching AI to budget its thoughts. L1's secret is LCPO, a training method that teaches the model to follow strict thinking budgets. Here, how it works. 2 modes for flexibility. L1 Exact: solve this in exactly 512 tokens. Perfect for tasks needing precision, like step-by-step math. L1 Max: use up to 4,096 tokens, but prioritize accuracy. Ideal for open-ended tasks like brainstorming. Reinforcement learning with a twist. L1 isn't just rewarded for correct answers. It's also penalized if it violates the token limit. Imagine training a chef to make a gourmet meal and clean the kitchen afterward. This dual focus ensures efficiency and accuracy. Adaptive reasoning. With tight token budgets, L1 focuses on critical steps, example double-checking calculations. With more room, it explores alternatives or explains its logic. It's like a writer drafting a tweet versus a thesis. Same mind, different strategies. Real-world impact: tiny model, giant results. L1 isn't just theory, it's shattering expectations. Math Olympiad problems. L1 Exact solves 22.5% of AIME problems in 1,000 tokens. GPT-4o, 100x larger, only manages 10% in the same budget. General knowledge. On benchmarks like MMLU, a quiz spanning history, science, and more, L1 matches GPT-4o's accuracy with 1/3 the tokens. Out-of-distribution tasks, L1 generalizes better than models that think longer without direction. Less fluff, more focus. Analogy alert: L1 is the AI equivalent of a chef who can whip up a 5-star meal in a microwave. Constraints breed creativity. Challenges and limitations. L1 isn't perfect. On non-math tasks, example trivia, its token length accuracy drops to 60–80% good, but not flawless. The model also struggles when tasks require unexpected detours. Example, realizing a math problem needs a geometry approach mid-solution. Extended training helps, but some kinks remain. Why this matters? L1 challenges the bigger is better AI arms race. By prioritizing efficiency, it opens doors for cost-effective AI. Smaller models equals lower energy use and faster responses. Customized reasoning need a quick answer. Use L1 Exact. Tackling a research problem, switch to L1 Max. Democratizing AI. Less reliance on billion-parameter behemoths means more people can run advanced models locally. The future: smarter, not harder. L1's success hints at a new era of AI design, where models aren't just measured by size, but by their ability to adapt. As co-author Sean Wellick notes, it's not about how long you think, it's about thinking the right amount. Final thought: if AI were a sport, L1 wouldn't be the strongest player. It'd be the one who wins marathons by pacing itself perfectly. And in the race for practical, scalable AI, that might just be the winning strategy.